Another example where we can use Ohm's law and Kirchhoff's law to make our calculations and find the values that are unknown, being R1, I1, R3, I3, R4. What we're doing with these examples is we're trying to see what resistor or what branch or what loop has 2 out of 3 unknowns for Ohm's law. So V equals to IR is Ohm's law. And we are looking for an application where there is 2 of those unknowns. Okay, so at the first sight, let's just have a look here. This this resistor here, what we know about this resistor is that it has 250 milliamps passing through it, and it has a voltage drop of 25 across it. So this here is 25 volts. I think that qualifies. So 25 as the voltage drop equals to 0.250, which is 0.25, multiplied by R2. That's how we are going to calculate R2. Then is 25 divided by 0.25, which is going to be 100 ohms. So we're going to write 100 ohms right here. All right. Now we are also going to see, okay, what else are we going to calculate here? Because this is going to be one of the ways we use Ohm's law and Kirchhoff's law. So Kirchhoff's law, if applied to this node here, what you can say is that 1 amp is going through this node, and then it is being branched off like that. So that 1 amp is coming here, giving 0.25 here, and the rest is going in that direction. So obviously 1 amp is 1000 milliamps, 25 of it going, 250 of it going here, leaves 750 here. So I could say 750 milliamps are going in this direction. And at that point, R1 becomes also something for which we know 2 values. So R1 in this case becomes V1 divided by I1 according to Ohm's law, and V1 is 25 volts divided by 0.75 or 750 milliamps. How do I know the 25 volts is applied there? Well, because let's just go step back and see how we're going to apply the nodes. So we have this node here, and we have this node here, shape an H, and then we have this node here. All right. Now look between the red and the green. You can see that R1 and R2 are sharing one node at one end and another node at the other end, meaning that they are in parallel. The rule for parallel is 2 resistors sharing one node at one end and another node at another end. And if they are in parallel, then they are going to have the same voltage drop across them. That's the basic rule of parallel circuit. So going back to the calculation here, let's put in the value, and the value is 33.33 continued ohms. Right, so that's right here. The value of R1 is 33.33 continued. Right, so what we're going to do next is we're going to see if we can make sense of the second set of resistors, which are at the bottom here. Now, do we know the voltage drop across this? All right, so first of all, the voltage drop between red and green is 25, and the voltage drop between green and blue is something that we need to calculate. But the voltage drop between red and blue is 50. So if 50, according to Kirchhoff's voltage law in this loop, for example, if 50 is generated in that loop, it has to be consumed in R1 and then R3 before it comes back here, meaning 50 volts is going to be equal to V1 plus V3. That's Kirchhoff's voltage law, right? Applied in this circuit here, or sorry, the loop here. So do we know V1 or V3? Well, we know V1. So V3 then equals to 50 minus V1 being 750 milliamps. Sorry, excuse me, 25 volts. Excuse me, 25 volts. So V3 is going to be 25 volts. So this here is going to be 25 volts. That makes sense because if we are generating 50 volts, it has to be consumed here and here in this loop. And if 50 volts is supposed to be consumed between R2 and R4 in this loop. All right, now I am going to write that 25, or I written 25, and let's have a look at this guy here, R4. We know the voltage drop, we know the current. So I'm assuming that we can simply calculate our value of the resistance. So R4 is going to be equal to V4 divided by I4. And in this case, it's 25 divided by 500 milliamps, which is half an amp. And that is going to be 50 ohms. So that's 50 ohms. Right now we're left with I3 and R3. Do we know I3? Well, we could definitely calculate I3 in this way. We know that the current that is coming here and being divided into two branches are going to also be collected here. So this current here is going to be the red that is going into green through the two resistors is going to be the 1 amp again. So the currents that are coming out of I1 and I2 are going to add up to 1 amp, meaning 1 amp is being divided again now between those two branches, R3 and R4. All right. So that is going to make life easier for us because we know that this branch is half an amp, 500 milliamp, which will make this branch also half an amp to add them both together to 1 amp, meaning that my I3 is going to be 0.5 amps or 500 milliamps. And if I know that, I can calculate R3 equals to V3 divided by I3. V3 we have established is 25 volts and I3 is 0.5, which makes R3 50 ohms. All right. So in this case, we have solved every unknown that is in this circuit using only Ohm's law and Kirchhoff's law.